if there are mud houses existing for so many years, and we know that they're eco-friendly and they have all the good properties we want, why no one is talking about it, and why there is so much of scientific gap in the knowledge with mud, which is like existing for 10,000 years, but we have every knowledge about cement or fired brick, which are or cement at least, which is more recent than fired brick. I do see a rising trend of growing interest in mud construction by, I would say, upper middle or upper income families.
Hello and welcome to another episode of Tiny Farm Friends podcast. Our guest today is Yask. He is the founder of Muddled Studio, a scientific researcher in the field of sustainable construction materials. I have been recently geeking out on his Ph.D. thesis titled Building Affordable, Durable and Desirable Earthen Houses, which he conducted at TU Delft, Netherlands. And I found it quite fascinating. And that is why I'm excited today to break down all the myths surrounding natural building and mud from a scientific perspective. So, thank you, Yask, for joining Tiny Farm Friends podcast. And before we dive deep into these topics, I'd love for our listeners to get to know you a bit better personally. So, if you could
Sure.
kindly tell us about your background, your interest, and how you got started in this field of natural materials.
Okay, so yeah, thank you for having me in this podcast. And to start with, I would probably have to go back to my end of my bachelor's. After my bachelor's, which was from Gujarat, a college called BVM Engineering College, I decided to pursue higher studies, master's studies abroad, and then went to TU Delft to study master's in geoengineering, which is study of soil essentially. And then during my masters, I worked on different like one material which I named concrete, and that material is made from cornstarch and sand and water, and then it's basically mixture of this material, which when you heat in microwave becomes very strong, like even 3 times stronger than the normal brick you have. So that was my
Interesting.
first introduction to natural material, but I can't say that it was sustainable. It was for sure natural and biodegradable. And after my master's, I spent some time doing a bunch of mixed stuff at TU Delft. And then I decided to take on a journey of 9 months or 2 year, 9 months. So I decided to come back to India, travel for 9 months, and with no very specific idea or agenda as such. I just decided I want to travel. And one of the things I figured out before coming to India is that mud construction, which is again a form of natural building, is an interesting topic. And I knew from basically from people that there are still mud houses in India, and most people who cannot afford, or have low income live in these houses. So the idea was, okay, in this 9 months, I will travel throughout the country, but also look for a potential PhD topic. And then once I started traveling, I went to different areas. And I happened to be in many rural areas where I saw for the first time physically mud houses. And then at that moment, I was like, I want to make a documentary on like mud houses. That was a idea which never materialized. And I basically started recording people, houses, taking some notes, and just speaking to people, and also volunteered eventually in some projects. And that's how I got introduced to building with mud, which is considered as sustainable architecture or habitat. So that was my introduction, which was through travels, a lot of travels, 9 months full of fun. And I also met other people who are involved in ecological practices like you. So I met quite some people and I also learned from them. And meanwhile, I also drafted a proposal which got selected at TU Delft, and then it became a PhD topic. So whatever I did during my 9 month trip was quite useful because it became one of the chapters of my PhD thesis.
That's quite interesting. And can you tell us more about your travel and this backpacking trip? Like, which areas did you go to? What were your learnings? What were your key observations when it comes to such earthen structures or mud buildings, and how are they perceived now in the rural areas?
Okay, so I went to quite some areas. So I started with Uttarakhand, People Koti. Then I visited Himachal, got to meet Didi contractor, had lunch with her. So and like that, I also went to Auroville, Tiruvannamalai, uh, villages in Jharkhand and Rajasthan and also Tamil Nadu, so multiple villages there. And I would like to talk about the village in also Odisha, and I would like to talk about this experience in Odisha, where I went with my friend who is Odia, and with him I went to visit this village which is nearby Raulkela, and there we got to talk to people, and that was one of the best interviews which I recorded as well. And there what we realized that people who are living in mud house do not want to live in these houses anymore, because and they want to have a fired brick or concrete house, and they see it as a sign of progress. So basically they
Okay.
gave this example: if you have a motorbike, your aim or your ambition is to have a car. If you have a
Right.
like a I would say, if you have a cheaper bike, you want to buy an expensive one later. So you don't want to keep on buying the same thing, or want to, choose something which you are not comfortable with. And that's what they said. So we see it as a sign of progress. And we have lived in mud houses, but we fancy fired brick and concrete house, which made sense. Like, there is no argument about it. So like that, and other experiences like in Rajasthan, near Jaipur, that village, and multiple other interviews I conducted in different parts of India. I found out that mud or earth has a low image, low societal image. And that's one of the barrier as well if you want to increase the number of earth houses in India or globally. It suffers from this low societal image.
Right. But what do you think is the biggest misconception around mud?
I think there are quite some many. One is if we talk about technical parameters, then it's related to durability, especially durability, which is like how it behaves in rain. And this comes from the fact that suppose if you're going to some area and you see a mud house which is not in good condition because it's not taken care of. Mud
Hmm.
house, traditional mud house always need maintenance. And in case someone is not maintaining it well, it can deteriorate. But there are also modern earth techniques which are much more durable. And talking about durability is that people also think from this point of view that, especially in urban areas, right? If you have a piece of soil, you throw it in water, it disintegrates, but a piece of brick or concrete will not. So even the personal experience of playing with small things or small objects or material gives you this idea that okay, concrete and fired bricks are more durable than mud or soil. But the reality is that we are looking at small scale when we are making this comparison. But when you look at a house level, a wall level, mud behaves quite differently than fired brick and concrete. And if you do a good job, which is like having strong foundation and like a nice roof overhang. If you take care of the design consideration, it's very durable or quite durable. And there are several examples of that throughout the world where, there are mud houses of 8 to 9 story high in Shibam, Yemen, and they have survived for more than 400 years, and other areas as well. So that area generally does not rain, but also in areas where it rains, there are mud houses which have survived well over the lifespan of concrete. So that's one myth which people think that's not water resistant, but it's not like that. You have to have a proper design and detailing to make it water
Right.
resistant.
So you mentioned,
And yeah,
sorry to interrupt you there, but you mentioned like we cannot compare like a brick size of mud and a brick size of concrete and brick. Can you talk more about it from a scientific point of view? Like, what is the
okay.
right comparison and what gives the mud its strength when you're talking about a bigger scale?
Okay. So because I was talking about durability, I will start with that, which is the water resistance property, and then I will follow up with strength. So let's compare small blocks, like small
Mm-hmm.
block of mud, compressed block, let's assume. Then we have small block of concrete and fired brick. You put it in water, fired brick and concrete. The the binding. So in concrete, cement is the binder, and the whole binding uh, is chemical. So it's basically chemically bounded material in that way. So there's chemical reaction which created some kind of product which are water stable. So it's basically chemical bonds are formed essentially in case of concrete because of
Right.
cement. In case of fired bricks, you also heat the clay at a very high temperature, which changes its properties. And again, this material which you have now is very different than the clay because it's been fired up. It's a ceramic material, again water resistant and has quite some water resistant bond. But when we talk about soil, soil is basically or mud block. It's basically mixture of clay, silt, sand, and gravels and other aggregates. And what
Right.
does say clay, silt, and sand means is basically it's the different sizes of soil particles. It's really about the sizes of soil particle, and every soil you see, apart from sea sand or pure sand, has some amount of clay, and clay is the binder in it. The thing is that when you put this clay in a water tank, or put this soil block which has clay in a water tank, the water will start going inside the material and will break the bond of clay with sand, and it's not water stable bond, and it's purely physical, and that's why it reduces that's why it gets weakened and the block disintegrates over like in short time. We call this capillary force is the key term here, because capillary force is basically when you make sandcastles on the beach and they stand there, it's because of capillary force. For that, you need to have some water in the system and not too much water, otherwise you cannot make sandcastle. And again, if it is too dry, 100% dry, you cannot make sandcastle. So you need some moisture.
Right.
Similarly, a mud block retains all its strength through capillary forces. That gives it strength, and capillary forces are very much function of clay in this case. Sand can also have capillary forces, but sand castles are not strong. But a mud block is quite strong, and that's because of clay particle which act as a binder, and then there is capillary forces keeping everything together. And once the water comes in, capillary forces decreases, and that's why the materials start disintegrating. So this is a small scale. But when one key difference is that your fired brick and concrete in general, they are like solid material which does not like breathe. So like our skin, mud blocks can breathe, and that means the clay in mud block can absorb and release moisture, which is
Okay.
a very important property. It helps in regulating temperature and regulating temperature and humidity. But one big part is that when you make a wall out of it, and when it rains, these walls can absorb this water and eventually keep on absorbing a certain amount of water. And there's a whole it will be quite technical, but there is a whole process of how water flows in these wall, and how after a certain point there's no space for water to move inside the wall, and that's why it just flows over the wall, and that's why it's
Right.
water resistant at a wall scale.
Okay.
I'm
That's
not sure
quite
if it was
interesting.
clear, but
So you talked about breathability, right? So why is it such an important element for human comfort or well-being? And if you could like try and make us understand in a brief way how it works chemically in the mud.
okay. So there is not much chemical about it. It's all physical with mud in general.
Okay.
Breathability is we refer it to as moisture buffering capacity. And that's like the property of mud to absorb and release moisture. And uh, why it is important, I will talk about two main points. One is about saving electricity bills. So if your walls and if your house can regulate the temperature, especially temperature, then you have to use less energy to cool the house or warm the house. that's
Right.
that's an important part. So it saves energy. It's also save cost on a longer run. So service cost of your house is reduced. Second is humidity, and again temperature, but very much related to humidity. We generally don't realize, but humidity should be at a certain level or range within the house. If it is below it or above it, either there's growth of fungus, or there's, sometimes when there's too much moisture, you can feel like, fungus growing,
Mm-hmm.
that kind of thing. That's
Right.
due to high humidity. And when there's low humidity, you feel like, it's very dry and it's coughing. So both high and low humidity is not good for human health. And that's why mud plays an important role, because it can take in high humidity, or soak, or absorb high humidity, and always maintain the comfortable humidity level, which is good for health. So these are the two reasons. You were talking about the science probably of moisture buffering, which is, I can tell you one simple example is, especially suppose when you're sweaty and you sit
Mm-hmm.
under a fan, what happens is evaporation of
Right.
water which is on you, and that makes you cool. The same principle is with mud. Mud, as I mentioned, can absorb moisture. So if it's sunny outside, then the water basically evaporates, which is in the mud wall, and that makes the mud wall cool. And
Interesting.
similarly, if it is too cold outside, the moisture is absorbed to the wall, which increases the temperature slightly. So it's basically the interplay of temperature, outside temperature, and humidity of the wall, or humidity or moisture in the wall.
Interesting. Thank you for those valuable insights scientifically. My next question is like, why did you take up such a topic, and what is your thesis a bit about? If you could explain us in a nutshell.
Okay, why did I choose the topic? It's like sounded quite interesting. My idea was to do something, or make or work on a project which also has an impact. And mud, I saw it as a material which can be used for making low income houses, or affordable houses in a way. So that was one of the interests. But I would say the real interest is also the curiosity that if there are mud houses existing for so many years, and we know that they're eco-friendly and they have all the good properties we want, why no one is talking about it, and why there is so much of scientific gap in the knowledge with mud, which is like existing for 10,000 years, but we have every knowledge about cement or fired brick, or cement at least, which is more recent than fired brick. So that was one curious point. And I like understanding materials at like even at a micro scale. So that sounded quite interesting for me. And talking about thesis, the thesis, in a way, if I very in simple words, it starts with that 9 month journey where I realized that image is a problem, and to improve the image of these blocks, it's very important to make it desirable, and the desirability depends on durability. And to make it durable, you have to add something to this material. It's mud house itself is quite durable, I must say. If you make a very nice design, it is durable. But modern aspirations are very different. So you have to prove and compare it with fired bricks and concrete that it is
Right.
durable. So people generally add stuff into it. So people either add cement or lime to make it more water resistant and strong as well. So, but I wanted to choose a route which makes it affordable, because cement prices are increasing. That's why it's not an affordable material if you're thinking of affordable housing. So that's why I chose local materials which are available in India, and one of the most common ones is cow dung. And then I have a whole study on cow dung, stabilized mud block, and I also did study on blocks without cow dung. Looking very much into the water resistance of it. So if I sum it up, it's basically about water resistance of mud block and cow dung stabilized block. And yeah, so that these are the key things I investigated experimentally. And there's a lot of theory, lot of literature study, and I also read a lot about all different kind of biological or natural stabilizer they are in scientific journals. So I also read about it in the thesis, and discuss about it as well.
Interesting. So you mentioned stabilizers, two kinds of stabilizers, cement and lime. And in this natural builders community, there is always this. I think there are two debates. One is cement versus lime. So my first question is, what do you make of that? And second is, should we add those stabilizers with mud? Does it make a good marriage?
Okay. So starting with cement versus lime, I technically speaking, if you are adding, if you have to add one of these, generally cement is preferable with a soil that has more sand, and lime is a material which you should add for a soil which has high amount of clay. So
Okay.
if you have to add, basically you have to assess the type of soil and then decide on lime or cement.
Hmm.
That's like the, I would say, more balanced view to approach which kind of stabilization is good for a soil. But reality is that people also look at the perception. So cement has a more negative perception and lime has a positive perception, which is also true because lime is, again, different studies say different stuff, but lime is considered more ecological, and it is more ecological than cement because it can absorb CO2 from the atmosphere over time and become
Right.
stronger. But the strengths are also very different. And cement is a material which has a higher strength than lime. So using lime is considered or perceived still natural by many. From a scientific lens, it does not make a difference. It's cement or lime because both are in a way processed limestone. In case of cement, you have limestone, which is the same material as lime, fired lime, but it also has other chemicals and clays, which gives it all this property and the color. So essentially, both of them are heated at a certain temperature. It's just that the lime absorbs the CO2 over time, so it's more ecological.
Interesting. And the next question was about adding them as stabilizers to clocks, what we call as CSEB. So, does the
True.
scientific community consider it sustainable, natural, or not?
True. So, like the practitioner community, scientific community also has two, I would say, groups. One is who does not like to add anything to mud, and also those who add it, they don't like that in general. So there is a big group of people who are like, just want to work without adding anything, and they consider that if you're adding cement or lime, and there are scientific article about it, which says that if you're adding more than 4% cement or lime, it's better that you go and build concrete structure. And many people do not believe that it is eco-friendly. They think it's like, just making a concrete building. Whereas there's another group of people, especially in India, the research is more done on cement and lime, where they feel that's the way to go about because it's more acceptable. You also guarantee some water resistance. You also guarantee some strength. Building codes are very important. Indian building code has a provision for cement or lime stabilized block, so you can build a house from these blocks in anywhere. But without cement, if you want to build something in city or a big structure and all, then it's legally it's more difficult because the provision is not there. But
Mhm.
talking about me, I worked without cement and lime, and my reasoning was not that I don't like those material, but it was mainly that I want to use something which is affordable to these two options and something which is more traditional and probably can impart more other properties. So yeah, I'm in that. So asking about it, which side I will fall into, I'm sort of in between. I feel that if you cannot guarantee good quality of design, and suppose you're making 20,000 house and government or someone else is making it, you are not really like supervising everything. Cement and lime is a safety barrier because you don't want to make a house which falls on, yeah, or disintegrates and result in any human casualty. Whereas if you have all the design resources, you have nice architect, and if you have all the know-how, then I highly suggest not going for cement and lime. Then you are making something truly ecological, and then you have something which is fully circular. Cement and lime blocks are, you will see studies are there which shows that it's circular, but you can imagine the amount of energy required to basically get the cement or lime out of soil or separate this mixes. It would be high. So yeah, it's very
Right.
context dependent. But I must say one thing, that in Europe, or I would say countries with high income, the trend is not to use cement or lime. Otherwise, it's not ecological.
Mhm. I think I would second your thought on this. And earlier, I was also too much idealist on just using mud,
Not
but
using it.
not using it. But now I feel that when things are out of control, and as you said, if the design is not right, that becomes a safety barrier. Fair enough.
Right.
And coming to the alternate of these two stabilizers, which you have done a thesis on, which is like cow dung. So wanted to
Yeah.
understand what makes cow dung water resistant.
Okay. So, like, if you take cow dung, liquid cow dung, and if you try to separate all its component, you will find majorly like two things: fibers and all the remaining black or smelly mass. These are the two broadly
Right.
simple components you can separate out of cow dung, right? So you have fibers. We know what are fibers. We use it in our construction as well, like as a reinforcement, and it's a good material. But the rest of the black material is like a black box where we don't know what it is made up of.
Okay.
And in my study, what I did is to separate the everything apart from fiber. I separated these components, and to separate it, you have to use like I would say a little bit of more high tech equipments to separate it. And once you separate it, you find that most of the cow dung, apart from fiber, is made up of something called fatty acids. And in
Okay.
my study, I found that a certain fraction of cow dung, which was responsible for water resistance. So not everything is responsible for water resistance. It's one portion of cow dung which is responsible, that contained fatty acids, and over 100 and I think 170 or over 150 compounds it had. So many chemicals mixed in this thing, and we classified that around 50% of fatty acids, which is also fatty acids are also available in your butter and oil. And butter is also very water resistant. You put drop of water in it, and it, like, it will slide through. So
Mhm.
it's same kind of fatty acids which repel water, which makes cow dung water resistant. And also, it's not just about cow dung, because when you add it to soil, it sort of forms bond with soil, and that bond is also slightly more water stable than without cow dung.
That's quite interesting for me to know. That these we just used to call them like some kind of bioenzyme, but these are actually fatty acids and comparable to butter. So quite intriguing.
Yeah, true. It's like outer cell or outer walls of the dead bacteria has these
Okay.
fatty acids.
Okay.
Yeah.
So what was the tangible result out of your thesis, and were you able to scale it from like a
Mm.
thesis level? Can you talk about that?
True. So, so there is tangible result out of it. So once we understood what makes the cow dung water resistant, we also tried to improve its characteristics, mainly focusing on water resistance, because strength is cow dung does not really improve strength actually. It's the compression process which can help you to improve the strength. So I focused on water resistance, and we understood very important stuff like how long you can store cow dung soil mix for, which can be years. You can store it for years without growth of fungus, which is very good for upscaling. Also, the smell of cow dung can be a nuisance for people who are not exposed to rural life, I must say. So
Mhm.
we also got a process to get rid of it, like simple process, a very simple process, just takes a few days, and the smell is gone. uh, and also, because I used compressed block, we could use a automated or semi-automated machine which can actually just you put soil in one, like mixture cowding in one, from one side, and soil from other side, and this mixer will automatically mix it, and then you have sort of a whole line or chain which is making these blocks. So we could produce a lot of blocks. And I started did my research on a block which was as small as, like, it was 4 into 4 into 4 centimeter cube, like a small one. But then we directly upscaled it to like bigger blocks, 29 centimeter and 15, or 15 would be the width, and 7. So like 7 or 9 centimeter. So we
Right.
had quite big blocks, and we went directly from the small block to bigger block, and we used it to make a wall to study how it works in the real scale. And this study is going for now 2 years, or the wall is there for 2 years, and you can see that the cow dung wall performs well. And we did all of this, which is like 6,000 kilos of cow dung, or 1,000 kilos of cow dung mixed with 6,000 kilos of soil in a day. So we could actually upscale it to a stage where you can do this kind of a mixing in a day, make all the blocks. So we made around 770 blocks in a day again. So we could do these things in a day, and used an industrial setup. And yeah, proper. We had proper pellets. Every like the other standard material, this was also made in a factory where the soil was available locally. So we had to transport cow dung.
Mhm.
We made the blocks and got this block to make a wall, and that wall is doing well. And this project eventually also became sort of a startup, or at least became a very popular project. And with another person, I worked on like basically applying it for Ugandan context, and the Dutch government is a wing called RVO. They supported us with funding. Now I'm not working on this project, but other people are working on it. So it's also being applied in practice. But anyone who wants to use it can use it. A lot of information is available in my thesis. There's also a video which people can just watch and learn like how they can improve the performance of their mud building by using cow dung. So these resources are there which people can use to apply it in their buildings. That's the idea.
That's incredible, and it's extremely kind of you to make it available for vast audiences. Because when we talk about these natural materials, there are companies which try and make like very tight patents and commercial franchisee out of it.
True.
But I am totally bullish on this concept, and I can imagine, hopefully, that there is an India where people are creating such things like in a decentralized manner. And since we are talking about setups, patents, the access to labs, and like institution and grants, so that brings me to my next question. Since most of our listeners are also students, and now they're
Mm.
getting aware about bio-based materials and natural materials, and they're looking for masters in these kind of subjects like say material design or
Yeah.
material research. So this one is a little bit personal question, that what is your suggestion or your experience of going to TU Delft, country like Netherlands, where we think that there's a lot of infrastructure and a lot happening. And what is your first-hand experience of it? Is it worth the financial investment? And second, like what brings you back to India after doing all this amazing
Okay.
research?
Okay. So starting with first question, if this question was asked like 7, 8 years back when I went for my master's, the fees was still okay. Like you could
Mhm.
afford it. But now the fees is very high. So whenever someone ask me about if they should go abroad for masters, as long as if their family can support them financially, or secondly they really want to go abroad and most likely work there, then can still suggest doing masters. The infrastructure is really nice. Also, if someone is interested in natural building, not necessarily that you have to do a very specific masters. There are there are now new courses, and also some institute like in France there is one which focuses on mud construction. But I feel when you do only one thing, you are also biased. So
Mhm.
I feel it's good to do a more generic masters, because suppose you're doing natural materials and then you lose your interest out of it, which happens as well with many people, then you should still have a degree which helps you to lend to other places. Infrastructure wise, I can tell you that universities like Delft or any good university, they have quite good labs. Also, in that way, IITs also have good labs. I won't say that they don't, but it's just that a civil engineering department at TU Delft will have resources which a material engineering department has. So you can go in depth of material in civil engineering department there. Whereas here you are limited. You have to collaborate with someone in material
Right.
engineering department for their resources. So it can get very tricky. And they have more like they have many technicians taking care of different equipments. And in general, they are also talking about TUDF. It's really good in materials, especially
Mm.
building materials. So I highly recommend someone who wants to pursue this thing, wants to either do a PhD after masters or wants to settle abroad. But if you want to go there, study, and come back, then you should have enough financial backing. Otherwise, it can be challenging.
Why do you
Yeah.
say PhD?
So most people decide for, so you can still do your masters in India and do PhD abroad. That's still a
Mhm.
possibility. But what I'm talking about is like in places like Netherlands or Switzerland, if you're doing your master, you're spending money, but your PhD salary is sufficient that you can recover the money you sort of invested in 2 years in
Mhm.
the 4 years of PhD. So you will if you do it like in a relaxed manner, not overspending and all, you can actually break even in your PhD, or just by the end of your PhD with the current fees. The previous fee was much lesser, so you could do it earlier. So you can break even there, and then you have a master's and most likely a PhD from a good university. And then generally people do PhD because they want to be professor.
Okay.
So yeah, so then that's a better. And then if you want to come back to India, having a PhD from abroad really helps. I must say. So
Okay.
that I recommend. If someone wants to do a PhD, maybe it's worth taking the risk. But fees are increasing heavily. So be careful and always talk to different people, which group, which research, or which department you want to join. Yeah.
That's valuable advice. And what brings you back to India? Like, what were the opportunities for you there in Netherlands, and what like brings you back?
Right. Uh, so this can be very it can be very diplomatic answer, but I will try to be really honest.
Yeah.
One thing is, I did feel that India, as we all know, the GDP or the in India is on a rising curve. That's what many people say. Many people believe it as well. And you have seen this trend that many people from US and Europe are coming back and doing some stuff in India. The opportunity to do something impactful, I feel, is high here. Although money is, if you're working here, I feel if you're working in after studying and after spending so much money there, if you're working here in a company, that might not work out really well, because then the outside you have much better work culture. That I have to agree, which is true. But if you want to do something very different, like different than having a job, then I feel India is a great place to just come try out things. Feel many people are nice and willing to help. There is competition as well, but that's a positive thing about India. And also it's a country you belong to, and you can you're not dependent on visa. Your parents don't have to travel, get a visa and travel and meet you. So I feel that those kind of visa restrictions you have in Netherlands, or especially for parents, like you can get a permanent citizenship, or permanent residency or citizenship, but parents won't get. So it's I felt that quite annoying thing. And that's why I thought, okay, if I'm in India tomorrow, I'm ill, my parents can travel. If they are ill, I can travel. It's much more easy,
Mm.
much more closer. That's one thing, like parents opportunities in India. I also felt that I stayed there for 10 years, roughly 10 years. So I also got a bit saturated in terms of work, and I wanted to be a professor always, but I changed that plan during my PhD. I was not 100% sure. Before, I was 100% sure for many years, and then I lost some confidence, or not confidence. I got frustrated with academic system, and I realized that if I have to thrive, either I have to join a company there, because I'm still dependent on, I still need a visa, so I need a company to sponsor or give me a salary and should sponsor my visa. So I have to work in a company, and I feel with my kind of work, there are some companies there, but it is still like, it's very more challenging in that way. And also you are doing something, but like Netherlands, countries like Netherlands are already developed. They, if you,
Mm.
to improve something, it's already here. You can just improve it to here. But in India, this gap is very high. So there is
Right.
more interest in that way, or more passion in doing stuff. That's all. Yeah. So it's like
Interesting.
that. So these are the key reasons.
Yeah, thank you for being so honest and transparent. And you mentioned about the opportunities in India. So, my last question to you before we end this conversation is, what is your vision for Muddled Studio, and what do you think the mud construction future looks like in India?
Okay. It's a difficult question for me. Muddled Studio is it's a very recent one. So
Mm.
I'm actually involved in other fellowships at this moment
Mhm.
with something called Unbox Labs. And my vision in general, whether it's related to Muddled Studio or just doing some other stuff in collaboration with others, so I'm not very much focused on just growing the studio. I would be happy if it grows, but also to do interesting stuff, whether I have to do it just as a individual consultant or as a model studio, is to multiple. One is to create more awareness on earthen construction, or mud construction, or in general natural building materials and traditional material, and for which I want to also focus on sustainability, how to calculate it, and I'm planning to make courses on it. That's one thing which I want to do, because education is education is very important to create awareness. Secondly, I do see a rising trend of growing interest in mud construction by, I would say, upper middle or upper income families. So I do see that there's a good future in that sector. uh, if you are into earth construction, and I see number of architects are also increasing there. And most of them have a background of architecture or sometimes structural engineering. I feel that my background is more related to soil, which is the core of earth construction, and I also understand bio. So in that way, I feel I can really help in multiple projects. Given infinite money, I would really like to have a setup where I can actually make these components of mud house already, and it can be either I have enough resources that I can do this thing locally with a specific machine, or I can do it in a certain factory like they do it in Austria. That could be a very interesting way, because I'm interested in materials in more than the houses actually. So my interest would be to have a very nicely equipped laboratory with all kind of equipments. Yeah, so I actually want to have a lab which has all kind of equipments, and we can actually invent or rediscovered many of the traditional recipe. That would be something amazing.
Wonderful. I can definitely say that my knowledge on natural materials has grown exponentially today. So, thank you for having this conversation and thank you for all the work that you do, Yask. It has absolutely been enlightening for me. Thank you once again.
Okay. Thank you, Raghav. Thanks for calling me for on this podcast.